Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI.
Thanks, Jim. Hey, everybody, and thanks for plugging into the TTI Distribution Download. I'm Steve Brahosky, and I'm a Connector Business Development Manager here at TTI, and I've been in the electronics industry for over 30 years, 4 of which have been here at TTI. In this episode, we're welcoming Gia Hayes, and Gia is a Vice President of Military and Aerospace here at TTI. And in today's episode, I think you'll find interesting. It's on electric vehicle takeoff and landing, eVTOL, as most people know it as. But before we begin, Gia, I'm happy to have you join me here today, and I'd like, if you wouldn't mind, to tell the audience a little bit about yourself, your experience in the industry, and your time here at TTI.
Sure. So thank you, Steve. I'm excited to talk about eVTOL. I'm a little bit of a space geek. I don't know if that's politically correct, but aerospace nerd, whatever you want to call it. So talking about some of these subjects that we have is super exciting to me. I've been in distribution for about 25 years. I've been with TTI almost 5. So we're coming up on a milestone. So
Nice.
Looking forward to talking about eVTOL.
Indeed. So as we talk through this subject matter today, my role at TTI is predominantly a supplier-facing role, and your role is primarily a customer-facing role. But our roles do overlap. We spend a lot of time together talking with both customers and suppliers. So as we work through the subject matter, I think the audience will hopefully ascertain and gain some insight as to what we experience here at TTI as we work with both suppliers and customers. So with that, let's go ahead and jump into it. So first of all, there's a lot of buzz about eVTOL these days as we look to the future and what to expect from the future with a lot of uncertainty surrounding it. Could you maybe share your thoughts with the audience on what eVTOL is and what it isn't?
Yeah, absolutely. eVTOL, so for those that aren't as familiar, you said it's electric vertical takeoff and landing. Some other acronyms that you might hear are UAM, which is urban air mobility, or even AAM, advanced air mobility. Some of the things that I believe it's not, even though it's compared to drones, it's really not a drone. It has some characteristics like a drone, and it's not just an electric version of a helicopter because it has so many levels of redundancy. It's going to be quieter, with it being zero emissions. It's better for the environment. Some people may ask, well, why all the hype? And to that, my response is always, eVTOL aircraft holds significant promise to really revolutionize urban transportation by offering us a fast, efficient, and a direct mode of travel within and between cities. eVTOL aircraft will bypass all that ground traffic congestion, reducing travel time and improving overall mobility. Imagine that you could potentially change the limits of what we can accomplish in a day. Say you live in Los Angeles and you want to go to Palm Springs for dinner or golf. I'm sure that interests you, right?
Absolutely.
Instead of a 2-hour drive, and that's on a good day, you might look at a 20-minute commute. Today's max range for eVTOLs is really between that 100 and 150 mile radius. It just brings a new way of looking at the boundaries that we have. And what I find most exciting is that it's designed to be inclusive. So it's not just a toy for the wealthy. It may cost the same or at least a similar charge as a taxi or a hired car service. So it really opens up this opportunity to a huge population globally that can benefit from this mobility. Estimated market size right now, by 2030 is well over $30 billion. Some analysts are predicting that over the next 20 years, it's in the trillions. So right now, it's really about the optimum balance between performance, cost, and speed to market. Of course, there's, still a lot of regulatory requirements, FAA type certification, airworthiness. Think about the infrastructure that still needs to be put in place too, before it really becomes mainstream modes of transportation. You can Google eVTOL, and there are some very well-known startups and OEMs, and they're telling us that they're very close to getting their certifications. And 18 to 24 months, you're going to see limited production, but you're still going to see eVTOL flying around some of these larger, densely populated cities like New York, New Jersey.
So to date, has most of the funding been private, or has it been public, or a combination of the two? Do you have any sense of that?
Yeah, it's a combination of the two. So there are publicly traded companies. You've got airlines that are investing. You've got car manufacturers that are investing. So the funding is real. The dollars are there, and we're certainly seeing these prototypes. Paris Air Show, we saw the unveiling, if you will, of several eVTOL aircraft. So there's a lot going on. And, with that, there's also a lot of electronic component content in eVTOL applications. So maybe I'll, ask you the question of, can you share some of the insights into some of the design considerations that engineers are grappling with today?
Sure, I'd love to do that. So, like with any aircraft, size, weight, and power, often referred to as SWaP, is a prime consideration for these types of vehicles. And certainly all that has to be factored in when you think about how many connectors and relays and sensors and cabling and infrastructure that has to be put into a vehicle that has to then take off using propulsion supplied by onboard batteries, which in and of themselves weigh a lot. Every pound, every ounce counts in terms of energy efficiency. If I were to kind of frame the infrastructures in a way for the audience to digest it today, I'd say there are three main categories. That would be power management, data management, and wire management, all of which affect different functions in the aircraft, including propulsion, flight control, navigation, cockpit mission systems, in-flight entertainment. And of course, as you would expect, all of these need rugged, reliable, fault-free, lightweight connectors and connector systems and solutions to allow these vehicles to actually properly function. So if I were to break that down into those subgroups, looking at power management as an example, with it being an electric vehicle, there's obviously a lot of high voltage, high current cabling and connectors needed for this type of aircraft. And some ranges could be up to 1,000 volts DC, 400 to 500 amps in terms of current carrying capability of the connectors themselves. Obviously, these vehicles need to be charged, so there's got to be a charging solution while the vehicle is on the ground. And then, of course, when it takes off, that power has to be transmitted from the batteries to things like the electric motors and the powertrain. And so oftentimes you'll see power bus bars used for power distribution within these vehicles. So that brings on another characteristic in terms of form factor that has to be considered as designers look at how they're designing solutions for power management on the vehicles themselves. Oftentimes you also see power and signal combinations of connectors for space savings and increased functionality. Likewise, you also see the use of both circular and rectangular connectors. Oftentimes lightweight, they're made of composite material. There's sealing requirements, latching, and ease of use functionality that has to be considered when choosing connectors of this sort. And then switching from connectors into the relay space, there's a high degree of need for power switching, both for high voltage and high power. So relays and contactors that are flight rated and are lightweight are used extensively in eVTOL type vehicles for the power management characteristics that are required. Transitioning from power management to data management, as you might expect on these vehicles, there's a lot of communication networks that are happening. These require high speed, high bandwidth, lower voltage. So unlike power management, this is lower voltage a type of connectors and cabling solutions. They oftentimes will be copper, but sometimes fiber and RF, fiber especially for the weight savings and for the functionality because of the higher bandwidth and speeds that are required. But network protocols, think like CAN bus or Cat5 and Cat6, even things like single pair Ethernet. So traditional Ethernet uses 4 twisted pairs and single pair Ethernet uses 1 twisted pair. So the connectorization and the cabling solution that goes along with single pair Ethernet obviously is attractive to eVTOL because of the size and the weight savings that are experienced. If you look at infotainment, obviously that requires high-speed internet access and high-speed networks, allowing the opportunity to save space and boost performance because of the need for infotainment on board while passengers are being transported between cities and locations. Something else that I've come to learn in talking to suppliers and talking to customers that are involved in this industry is that there's applicability of products that are used in, I'll say, commercial aviation, industrial, and even terrestrial electric vehicles that have applicability to eVTOL. You know, in the circular connector space, an example of that would be the 38999 connector that's used extensively in military and aerospace and defense systems. Typically, they're used or have metal shells of different forms, but because of the weight requirements of eVTOL, as I mentioned earlier, sometimes the composites will be used with respect to a circular connector to help achieve some weight savings. Likewise, ARINC, which is a widely used rectangular connector system, a lot of times used in avionics and other commercial aviation type applications. Those are also being used in eVTOL, but again, sometimes in composite form or even in smaller form factors.
Sure. Like SWaP, you started with that earlier, size, weight, and power. So when you think miniaturization, nanos, micros, can you elaborate a little bit on that?
Yeah, if you look at just a normal subminiature D, which is a connector system that's been used since the 60s. They now make them, of course, in micro and nano Ds, and there's mil specs that surround those connector systems. So sometimes the composite materials will be introduced to allow that small form factor to even achieve a higher degree of weight savings for engineers to consider for applications like this. Or even looking at, I mentioned earlier, the 38999 connector, there are connector systems that are coming out today that use mil spec qualified components, but in a smaller form factor that can have weight savings of 30% and size savings of 70%. So you're seeing a lot of use of miniaturized connector systems in applications, including eVTOL.
And that's a big deal because when you think about an eVTOL, it's got a pilot, potentially 4 passengers. There are weight restrictions that are less than what you might realize. I mean, I've read 1,000 pounds. I mean, that's not a whole lot for cargo. Right. So when you're looking at weight savings, I think they have to look for every option available.
Indeed, no doubt. And then beyond just connectors, there's a prolific use of sensors in eVTOL applications or in the vehicles themselves for things like flight control, positioning, temperature, altitude, all those sensors. As they collect data, the data has to be moved around, and that's where we get back into the data management and the form factors that are required, both for in terms of connectors as well as the cabling of those connectors for solutions that allow those applications to happen. So now moving into the last infrastructure that I mentioned earlier, that being wire management. If you think about these vehicles, and if you were to peel back the skins inside these vehicles, obviously there's a lot of wire and cabling that's used. Oftentimes it's copper, but sometimes, as I mentioned earlier, it could be fiber or other form factors. But all that, the routing of that wiring within the aircraft and the spacing between these sections in eVTOL is a little bit different than commercial aircraft because all these vehicles are different. So the wiring mechanisms and the wiring guides that are used are all a little bit different, but they all have similar characteristics in that because the aircraft is made of composite and because of the weight considerations that we've mentioned throughout this podcast, system attachments have to be looked at a little bit differently than you would on a commercial aircraft. And beyond just the attachments and the routing of the wires within the body of the vehicle, the aircraft, adhesives have to be considered as well because most of these eVTOL fuselages are composite. So punching holes like you could do in a commercial aircraft, like a Boeing as an example, in the airframe is just not something that's very desirable, I'll say. So using adhesive solutions for standoffs or anchors or even clamps in place of bolt-down hardware options, again, saves weight and reduces the risk of floating object debris, which is a very big concern with any aircraft. So unlike traditional aircraft, things are a little bit different with respect to wire management, especially when it comes to weight savings and the adhesives and composites that are used. So Gia, now that I've covered some of the component selection challenges and considerations, what role does TTI or distribution play in this fast emerging industry?
TTI is obviously well connected, and yes, pun intended, to all of the major IP&E suppliers in the aerospace industry. And with eVTOL truly being more of a hybrid technology, taking aviation into consideration, as well as some of the industrial and automotive concepts into account, TTI has suppliers that are coming to market with really unique solutions to support this subvertical, regardless of the challenges our customers are facing. And there's still a lot of hurdles for eVTOL. Safety, obviously, establishing operational and mechanical safety records, the infrastructure that's still being built. You've got FBOs or fixed-based operators out there that are converting portions of their hangar into electric charging stations for eVTOL. Think about air traffic management, integrating eVTOL with other systems, regulations, and then think about the psychological barriers. You have to have the buy-in from your consumer, and so a lot of this has to be proven before they can, market it to the masses. Mm-hmm. And then one of the roles that TTI plays, obviously, is to connect the OEM design engineers with solutions provided by supplier partners. So this linkage, that will help provide vital information to our customers as they're looking for, collaboration on the design work. Engineers may have products that they're utilizing, but maybe they want to modify it. TTI can bring in multiple options to the table depending on what the ask is. We also have awareness of what's been successful in the past, and by sharing information, we can find the right solution. We have a host of materials and literature on our website. We have field resources in our branches. We have corporate subject matter experts, and then not to mention a family of specialists, which includes other electronic component technologies. So we can help facilitate those discussions as well. TTI's broad vision across the supply chain will make this process more efficient for the OEM. And of course, beyond design, TTI has supply chain fulfillment solutions in the form of inventory and materials management, which we are very well known for in the industry. So there's really no opportunity that's too big or too small. So I would just say that, if you have something that you need help with or collaboration, reach out to us, through your local contacts, through our website, or you can even contact me directly. I would love to talk about eVTOL.
Wow, you're very passionate about this, Gia.
I am. I think it's so exciting. And, this is really going to change some of, aviation as we know it. I love the affordability piece of it. Now, will I be one of the first to hop on? I don't know.
I was going to ask you.
I don't know. I might consider it.
Yeah.
We'll see. Time will tell.
Time indeed will tell. But really appreciate you joining us and sharing your knowledge and your insight on eVTOL as you talk to customers, and perhaps as I shared with respect to the supplier component to this as we look at applications and solutions. You said it very well in terms of access that we have to suppliers, all of which, at least in the harsh environment, military aerospace portion of our industry, have a portion carved out for eVTOL because they see it as an emerging market that cannot be left unattended, because this is going to happen. It's just a matter of when. So,
absolutely.
Yeah, really appreciate you sharing the insight. We look forward to future episodes with you on emerging markets that will propel the commercial aviation market in the next phase of air transport.
Yeah,
and
thank
I want
you.
to thank the listeners for
appreciate
plugging.
the conversation.
Yeah, I enjoyed it today. It's obviously something that's pertinent to the world we live in today and the future we're heading here in the next few years. Also want to thank the listeners for plugging in with us today, and I ask you to please tune in again for our next distribution download. Thank you.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.